Okay, hello everyone. In this video, we're going to do the 2009 AP Physics B Form B free response question number 1. And we're going to do this because A, it's a really good centripetal force and circular motion problem, and B, it will introduce you to the experimental questions and the line of best fit questions. So, in the AP Physics 1 exam. All right, so part A is to derive the equation P equals 2 pi times square root m1r over m2g that relates P and m2. Okay, so what do we do here? Now, let's draw like a little diagram. So you have this thing. You have, well, what is a centripetal force in this point? So let's think. So let's first start at M2. M2 will be M2G, M2G, and it's trying to balance out the tension force, right? But you can see like a third law pair here. The tension force will be pulling on M1, but M1's also generating another tension force that's pulling on M2. So you could see that these are both of these tension forces must have the same magnitude, right? So we can put that tension is equal to M2G. So M2G will be the centripetal force. So FC will equal T, which equals M2G. All right. So M1 V squared over R. And if you don't know where that equation came from, it is basically applying Newton's second law to the centripetal acceleration equation, then solving for net force. And there are no other forces acting on it since friction is negligible, it's a frictionless table. So this will basically be our equation. So this will basically be our net centripetal force. M2G equals M2G. All right. So we can isolate V squared by multiplying both sides by R. Multiply both sides by R and dividing by M1. So V squared equals M2GR over M1. Okay, but we're not asking for V. We're asking for P. Okay, so we're being asked for P. But V is equal to delta X or delta T, right? That's basically the definition of velocity. So if P is the time it takes for one complete revolution, because P is a period, so we're assuming it's the period of revolution, that means in this time P, it should go all the way around once. So it should be 2 pi R over P. All right. So that'll be 2 pi R over P squared equals M2GR over M1. Okay, so we get 4 pi squared R squared over P squared equals M2GR over M1. And we see that this R and this R can cancel, so we're left with M4 pi squared R over P squared equals M2G over M1. You could divide by 4 pi squared R, so you get 1 over P squared equals M2G over 4 pi squared M1R. Now you could take the reciprocal of both sides, so you can actually get p squared, 4 pi squared m1r over m2g. Take the square root, and you're left with p equals square root of 4 pi squared m1r over m2g. Right? And you can simplify the radical. 4 is a perfect square, so you can pull out 4 and you'll get 2 in the front. Pi squared is a perfect square, of course, so you could pull out pi squared and get a pi up front. So we're left with p equals 2 pi square root of m1r over m2g. So we're done with part A. Right? We derived the period equation that they gave us, that they told us to derive. So the procedure is repeated, and the period P is determined for 4 different values of M2, where M1 is a constant 0.012 kilograms, and R is 0.80 meters. So the data, which are presented below, can be used to compute an experimental value for G. So what values should be graphed to yield a straight line with a slope that could be used to measure G? All right, so let's look at our period formula. All right, so let's try to see if we can form a linear equation where G could be represented as a slope. Okay, so that basically equals let's square both sides. So p squared equals 4 pi squared m1r over m2g. Okay. Now, what we can do is we can we can take the reciprocal. Or actually, you know what? You don't even need to take the reciprocal. Because if you're sneaky and you're clever, you can see this sort of follows the equation for slope. So with the equation y equals mx, where y is equal to p squared, x is equal to 1 over m2, and the slope m is this 4 pi squared m1r over g. That doesn't really matter because neither m1 or r change. So this is an acceptable value for which you can find g, which you can use to determine g, because they don't ever ask that the slope be g, because that's not like feasible, especially in this type of expression. So you have to use quick thinking to find out a slope that involves constant terms and g. Okay? So let's use these 2 columns to find 1 over m2, which will be our x, and p squared, which will be our y. So p squared and second squared, 1 over m2 in kilograms, -1. So 1 over m2, that's 1 over 0.020. That's 50. That's 50. Then we have 1 over 0.040. That's 25. Then you have 1 over 0.060. That's 16.67. Then you have 1 over 0.080. That equals 12.5. All right. So now we can find p squared, right? P squared is 1.40 squared is 1.96. 1.96, and then we have 1.05 squared is 1.1.102. Then we have 0.80 squared equals 0.64. Then you have 0.75 squared will be 0.56. All right. So what quantity? So p squared and 1 over m2. So if you don't understand what happened, see if we write this as, sorry about that, p squared equals 4 pi squared m1r over g times 1 over m2. Now it's easier to see the equation, the linear equation, right? Y equals m x. So it will go straight to the origin, where m is our 4 pi squared m1r over g. Okay. Whew. So let's actually graph this. So first we have to label. X-axis will be 1 over m squared. Sorry, 1 over m2. Kilograms, -1. And our y will be p squared in second squared. Okay. So, all right. So what we can do is you can graph right now. So what are we going to scale the p squared with? So we want something that reaches from 0 to 2. So we could just label it by 0.50. Because we want something that reaches 2, because 1.96, the very first term for p squared, is very close to 2. So 0, 0.5, that's 1. 1.0, 1.5, 0, then 2.00. Okay, and you just have to label it. For this one, we can just label it by try to find something that's a little greater than 50. All right, let's label it by well, you could label it by 50, but it will just be at the very edge. But fine, we'll just label it by 10s. But 50 will be at the very edge of the x-axis, so it'll look a little unneat, but as long as it gives us good data, it should be good. All right? So this graph, so for first one, it's 50 and 1.96. 50, then 10, 20, wait, 60, 70, 80, 90. So it should be around here. All right. Now our next point would be 25 and 1.102. 25, so dead center, 1.102. 1.02. So about here. Then 16.67 and 0.64, so 2/3 the way through. This is about here. That's 3/5 right here. Then 60 and 6.67, 0.64. So 60 about here. Trying to preserve accuracy. And we have 0.7, sorry, 1 over m2. So 12.5 and 0.56. So 12.5 is over here. So over here, 12.5, 15, that means this is 12.5. All right, it's 12.5, and we have 0.56. So 0.56 about should be 50, 60, so about here. Let me just check if my graph is all good. 1.102, 1.6, then we have 0.5. All right, we have our little point right here. So let's draw a good line, a line of best fit. Let's try to find a line that best. Just these two I'm having trouble grasping. Right. So I'll just draw this as a good line, right? So we've graphed. So part D, use your graph to calculate the experimental value of G. All right. Okay, so let's find 2 points that are very, like, it goes right through. So we can be accurate for our measurements. So I'm pretty sure this one is extremely close. So I'll circle these so we can know that not to mess with those points. So that is 0.224. So that's 0.24. So not 0.24, I'm sorry. 24. 24 and 0. Sorry, 124 and 1.00. So that's x1, y1. That's 0.1. So x2, y2. X2, y2 will be, so let's find another point that goes right through. It's going to choose this one right over here. Oh, no circling. Will make us even more confused. 32, 34, 36. So 36 and 1.50. So it's a pretty neat relationship. It's a pretty good line. So let's use our slope formula. So let's do m equals y2 minus y1 over x2 minus x1, which is equal to y2 1.50 seconds squared minus 1.50 seconds squared minus, sorry about the delay, 1.00 seconds squared over 36 inverse kilograms. Not a very common unit, but just since we took the inverse of the mass, the reciprocal of the mass, we have to use this unit. minus 24 inverse kilograms. And let's see what we get. We should get a pretty even number. 1.50 minus 1.00 divided by 36 minus 24. Well, turns out our m equals 0.04. What's our unit? So second squared over kilogram inverse kilogram. Or that's second squared over times 1 over inverse kilogram, so kilogram second squared. Kilogram second squared. But that is not G. If you notice, these are not the units for G. This is not G. This is our slope. Erase extra stuff. Right? So this is not G. If you want to find G, you used our expression over here. Right over here. So expression. So M equals 4 pi squared M1R over G. So if you multiply both sides by G and then divide by the slope, we use capital M for slope. So I need, just to avoid confusion with the M1. So we have G equals 4 pi squared M1R over our slope, which I'm going to use capital M for. Usually use lowercase m. So that gets us 4 pi squared times M1, so 0.012 kilograms, times R, 0.08, not 0.08, 0.80. Be careful with how you put in your numbers. That over your M we just got from our graph, about 0.042, more exact value, kilogram second squared, and we get a G of just 4 pi squared Four pi squared times 0.012 times 0.8 divided by 0.042. So I'm going to use the exact value. So we get about 9.1. 9.1 meters per second squared. Just close to our actual. So maybe just our line or the measurements, and actual friction, but this is the G we get from our graph. Should be acceptable. You might get a different one if you attempt this problem because of your line, but it's what I got. So this is the gist of how to do this problem. So if you have any questions, just comment on the video below and I'll try to answer them. Thanks for watching.